Hello my dear children of class 12 science. We do continue today with the chapter interference of light. This is one of the important chapter in wave optics, and in today's class we complete this chapter because we are solving some important numerical based on the Young's double slit experiment. Okay, so in the last class also we were solving the numerical problem till number 5. Now in today's class we solve two more numerical. So we will solve two more numerical, then this chapter get over. So after the completion of this chapter, we will even start a chapter that is diffraction of light. And diffraction of light, the chapter will do the last chapter as per reduced syllabus sent by the council. Okay. So problem number 6. So we start with problem number 6. Problem number 6 is that in Young's double slit experiment. Okay. So look at the question. In Young's experiment, simply Young's experiment, the Young's double slit experiment, the wavelength of light used is 6000 Armstrong. So let me just write the solution first, and we start doing this problem. And this 6000 Armstrong is the what? Wavelength of light. And you know wavelength is symbolized by letter lambda, and that is 6000 Armstrong. So what I do, I convert this Armstrong into meter. So 6000 into 10 to the minus 10 meter, because 1 Armstrong equals to 10 to the minus 10 meter. Okay, so remember this, to convert Armstrong to meter you have to multiply by 10 minus 10. So this can be further written as 6 into 10 minus 7 meter, because 30 means 10 to the power 3, so 3 minus 10 means minus 7. So you can write this way also. Okay, the distance between the two slits is 0.05 centimeter. Distance between two slits means small d, and this small d is also given 0.05 centimeter. But this centimeter I have to convert into meter. So what I do, I multiply this quantity by 10 to the minus 2, and this will be in meter. So children, remember this, to convert centimeter to meter, multiply by 10 minus 2. Okay, and the distance of the screen from the slit means capital D, that is 1 meter. So lambda, small d and capital D are known. So from here what we need to find out? Find out the distance between first dark fringe and first bright fringe. See, in this question we are not asked to find fringe width. Now we have to find the distance between first dark fringe and the first bright fringe. So in order to calculate the distance between first dark and first bright fringe, so I use the formula that since the distance of what? There is a formula out here, we use the distance of mth. I am writing mth dark fringe. The distance of mth dark fringe is given by xm, and the distance of mth dark fringe is equals to xm, and the formula is 2m minus 1 lambda d by 2d. So children, we have done this part also. Xm is the distance of mth dark fringe, which is equals to 2m minus 1, okay, lambda d by 2d. Okay, so this is the formula I use. Okay, then after we have to find for bright fringe also. I have to find for what? Bright fringe also. Now let me substitute the value. So in this question we can substitute the value, but what is the value of m1? Because we are dealing for first dark fringe. So for first dark fringe, m should be 1. So I don't 2 into m is 1 minus 1 lambda d by 2d. So because m equals to what? 1. So m equals to 1. This is for first dark. This is for first dark fringe. Okay. So for first dark fringe, m should be 1. So 2 1 is 2, 2 minus 1 is 1. So it will be lambda d by 2d. Okay, let me just write it down this way. So and I write m equals to x1. If I put m equals to 1, then I write on x1. So this is the distance of mth dark fringe from the center fringe, which is x d by 2d. Similarly, I do calculate for the distance of first bright fringe also. So for first bright fringe also there is a formula. See the distance of what? The distance of mth bright fringe. The distance of what? Mth bright fringe is given by xm dash. Okay, let me write this way also, no problem. Xm dash, okay, is equals to m lambda d by d. So there is a formula for bright rings, to find mth bright rings, okay, especially this distance is from the center of rings, it is xm dash. Let me just mark dash. So xm dash equals to m lambda d by d. But we have to find for what? Which bright rings? We have to find for what? First bright rings. So for first bright rings, m equals to m equals to 1. This is for first bright rings. First bright rings. So m equals to 1. So substitute. Let me substitute this value of m equals to 1 in the expression. So it will be x1 lambda. x1 dash equals to m is 1 lambda d by d. So this is x1 dash and this is x1. Now in the question we are asked to find the distance between first dark and first bright rings. To find the distance between first dark and first bright rings, the distance will be calculated by x1 dash minus x1. Means the distance between first dark and first bright rings is equals to x1 dash minus x1. Now x1 dash is the distance of first bright rings. Then x1 is the distance of first dark rings. And you know children, in case of interference, Young's double slit interference, okay, center will be bright. Then only it will come dark, then bright. So if you move from center rings to the fringes, then first will be dark, then after bright. That's why the distance will be x1 dash minus x1. So let me substitute the value. x1 means how much? Lambda d by what? Small d. Minus x1 is only how much? Lambda d by what? 2d. So I substitute the values. Now let me just take the LCM of this expression. So the LCM will be how much? See? LCM of d and 2d is what? 2d. So LCM will be 2d. Now d divided to 2d is 2. 2 is the remainder. 2 into lambda d is 2 lambda d. Minus 2d divided by 2d is 1. 1 into lambda d is lambda d. Now 2 lambda d minus lambda d means lambda d only. Now we can calculate the value now, and it is coming lambda d by 2d. It is lambda d by what? 2d. And children, we know everything. So let's substitute the value. So lambda means wavelength, which is 6 into 10 to the minus 7. Okay. D means 1. Distance is 1 by 2 into small d. The small d is value is given, which is 0.05 into 10 to the minus 2. Okay. So now let me do the calculation. 2 1s are 2, 2 3s are 6. Now power I'll take in the numerator. So I write on 3 into 10 to the power minus 7, and this is 10 to the power 2. Okay. By 0.05. Now we can remove the decimal and cancel. Okay. So if I remove the decimal, it will be 300. I can write 300 by 5 into 10 to the power minus 7 plus 2 means minus 5. Okay, minus 7 plus 2 means minus 5. Now we can divide. 5 1s are 5, 5 6s are 30. So it will be how much? 60 into 10 to the power minus what? 5, and this is what? Meter. 60 into 10 to the power minus 5 meter. But I can write this even as 6 into 10 to the minus 4 meter. Yes, I can write 6 into 10 minus 4 meter. Now even I break this power as 6 into 10 minus 2, and I can write this as 10 minus 2 also. Okay. Now writing this way, because 10 minus 2 meter means actually 1 centimeter. Okay. So it will be 6 into 10 minus 2 centimeter can be written. But 6 into minus 2 centimeter means 0.06 centimeter. So we can leave the answer in what? 0.06 centimeter, because this distance is very very small, so we write in the smaller unit only. That's why the answer will be 0.06 centimeter. So what is the distance between the first dark and the first bright rings? Is very small, which is 0.06 centimeter. So this is one of the important problem we have solved based on Young's double slit experiment. Now we have last problem to solve, and that is problem number 7, and that you learn in the next YouTube video.